Christy Carlson Romano. I play Ren Stevens on Disney Channel's Even Stevens, and I'm the voice of Kim Possible. You know, the wonder teen who saves the world, does her homework, and updates her wardrobe all on a school night? Yeah, well, she uses math, science, and technology to fight off evil villains. But seriously, I have some really cool friends who find these subjects helpful in solving real problems. They are the Treehouse Detectives, and you can meet them on NASA's Sci Files. They're going to be traveling to places that we can only dream of going. So, join in the adventure and help the Treehouse Detectives solve their newest case.
Don't forget to look for the answers to the following questions. Why is it important to find water ice on Mars? How will the Phoenix Mars lander analyze soil and water ice on Mars? What is ferrofluid and why did NASA develop it? When you see this icon, the answer is near.
So, good job, Bianca. Next time I think we need to slow down a bit because I don't want you to pull muscle or anything.
Actually, I was thinking about picking up the pace a little.
Me too, but let's think about this realistically. We still have a few years before we have to take the physical test to be astronauts, and I think we should take it easy. You know it first.
RJ, we're talking about possibly being the first astronauts to travel to Mars. I think I'll go ahead and run home.
That's 2 miles. Have you considered speed walking?
It's okay. I'm expecting a letter.
I think I'll just shoot for going to the moon.
Hi, RJ. Are you okay?
You look awful.
Tony.
I mean, awfully fit.
Bianca's killing me. I can't hide it any longer. I mean, I'm running twice a day just to keep up with her.
Why the sudden interest in physical fitness?
Remember what Mr. Gregory said? We could actually be the first astronauts to go to Mars. And you have to be in great shape to be an astronaut.
Yes. And in the case of the biological biosphere, Ms. Shepard told us about how astronauts have to train to stay in shape, both on Earth and in space.
We also learned that you can overdo it.
Getting in shape shouldn't mean you have to run yourself into the ground.
Maybe that's why NASA has manned and unmanned missions.
Did you say manned and unmanned?
Sure.
With the way my fitness training is going, maybe I need to think about working on an unmanned mission.
Good idea. Not that you're not in shape, but Mr. Gregory did say that NASA not only needs future astronauts, but also researchers, engineers, and scientists.
And GFPs.
What's a GFP?
Galactic Financial Planners. Come on, guys, get with the program.
Actually, Tony has an interesting point. I'm sure there's lots of ways to get involved with space exploration.
Yes, NASA needs lots of people in all kinds of careers. We just need to find one we like.
Let's bring up the problem board.
What do we know?
We know that there are both manned and unmanned missions to explore space.
Exactly, and we also know that there are missions that involve going to the moon, Mars, and beyond.
We also know that NASA needs space explorers and scientists.
Okay, so what do we need to know?
We need to learn more about unmanned missions and what it takes to be an astronaut.
I'll check out the NASA website. The NASA website is the perfect place to find out about future NASA missions and space exploration, along with careers.
Perhaps I can do something in R&D.
R&D?
Oh, research and development. Because, as you know, I'm a big fan of research.
Well, this may be right up your alley, RJ.
What is it?
I've contacted Dr. Carol Stoker. She's working on the latest NASA Mars mission. It's a lander called the Phoenix that the University of Arizona and the NASA Ames Research Center are developing.
Isn't Kaylee in San Francisco doing some research on redwood trees?
Yes, she doesn't get back until next week.
I'll send her an email to see if she can talk to Dr. Stoker.
Great. Maybe we should talk to Dr. D, too.
Maybe he'll have some ideas about manned space travel.
Actually, I was supposed to meet Dr. D at the Virginia Air and Space Center to check out a new exhibit on strange matter. I better run.
We're very excited about the new vision for NASA, space exploration, and the Phoenix lander. But we are just wondering why we want to explore Mars instead of some of the other planets.
Well, Mars is the planet in our solar system most like Earth, and it also may be another home for life.
What do you mean?
Well, some scientists think that life may have evolved on Mars early in its history when it was warmer and wetter than it is today. But the exciting thing would be if life still exists on Mars now.
That's very exciting. So why don't we check it out instead of sending unmanned missions to Mars?
Robotic missions cost less, and they help us learn a lot about the surface of Mars. The more we know about Mars, the more information we have to help design more effective human missions.
That makes sense. So where will the Phoenix lander explore?
The Phoenix will land in Mars' northern Arctic plains between 65 and 75 degrees north.
Why is it landing there?
The landing site was chosen because another mission to Mars, called the Mars Odyssey, has discovered near subsurface water ice. That's water ice that's under a layer of dry soil that's fairly thin, right in that location.
Why is water ice so important?
Well, the simple answer is that water is the most important ingredient for life, but it must be liquid water. On Earth, wherever we find liquid water, we find life.
But isn't ice the solid form of water?
Yes, but recent climate studies and climate modeling indicate that ice at the surface or near the subsurface in the area where Phoenix is landing may melt from time to time under some circumstances.
And melted ice means liquid water.
That's correct. And when the water's liquid, microbial life could be growing in the soil and then become dormant when conditions get harsh.
I learned at camp that when a plant or animal is dormant, it's inactive, sort of like sleeping. It's not actively growing, but it's protected by the environment until conditions are favorable for it to grow.
That's right, and on Mars, we hope to find that when conditions become favorable, the ice melts and organisms wake up and grow.
How will you know if there are microbes in the soil?
Well, Phoenix won't be able to actually detect microbes in the soil, but it will be able to determine if the environment was ever habitable, and it may detect things left by biology in the past, such as organic compounds and other clues.
But how will it be able to analyze the soil and water ice?
There's a robotic arm with a digging tool designed to dig into the subsurface and scratch and obtain samples of the soil and ice. Those samples will then be placed into instruments that will analyze the samples for such things as the type of minerals in the soil, any organic compounds, the chemical properties, and much more. The data will help us determine if the environment would be a good one for life.
That sounds so exciting. I can't wait till the Phoenix lands on Mars.
Well, it doesn't launch until 2007, but in the meantime, there's lots of exciting things going on at NASA to hold your interest.
Thank you so much, Dr. Stoker.
You're welcome. Don't hesitate to call if you have any more questions.
Hi, Tony. This strange matter exhibit is really cool, and it's a great place to learn about manned missions to space.
Strange matter? I don't see the connection.
Space is a very harsh environment, and for people to explore space, we have to overcome such problems as meteoroids and other space debris colliding with the spacecraft.
I never thought of that. I guess it could be very dangerous. So, what can we do?
Couldn't you shatter the glass with a bowling ball, because it is specially tempered glass?
Thankfully.
Space is really important to have materials that don't shatter upon impact. The International Space Station, for example, has layers of Kevlar that prevent micrometeorites from penetrating.
Isn't that the same stuff they use for bulletproof vests?
That's right. I've got a Kevlar glove right here. Check it out.
Wow, that must be a really tall blade.
Let's see how this works on an ordinary glove.
I'll take the Kevlar glove.
Good choice. Now, what else about space is harsh?
Well, I would think it's extremely cold in space.
Yes, it is. Insulation to protect from extreme heat and cold is critical, like the display on soap foams.
It's pretty impressive. What does that have to do with insulation?
Let me show you. Here, take this piece of aerogel. It's sometimes called frozen smoke. It's the world's lightest solid, which means it's the least dense.
You're right. It weighs a lot less than I thought it would.
A piece the size of a human body would have a mass of less than half a kilogram, or about a pound. It's mostly air, about 99.8%.
Oh, I see. It's like the soap bubbles. They're mostly air.
It turns out that air does a great job of insulation, either keeping heat out or preventing heat from leaving. Let me show you. Here, hold this balloon on the opposite side of the aerogel from the microtorch. Now move the balloon up.
That torch looks mighty hot, but nothing happened to the balloon as long as the aerogel was right there.
Try touching the aerogel. Is it hot?
No, not at all.
Aerogel was used to insulate the Mars rover's Sojourner from intense swings in the Martian temperature. NASA is experimenting with aerogel now to see if it can be made more transparent and used as a window.
What about radiation in space? Isn't that a difficult problem?
That's right. Astronauts need protection from radiation. The atmosphere and the Earth's magnetic field protect us from these things. But on a journey to Mars, for example, it's especially important to have shielding.
So will they use lead? I've heard that it stops a lot of radiation.
It does, but it's way too heavy to haul into space, and it has some other problems.
So what's the solution?
Well, NASA is experimenting with a lot of different ideas, but one of them involves this.
Dr. D, you've got to be kidding. That's a grocery bag.
It's called polyethylene plastic. Of course, it would have to be thicker than this. Another possibility is liquid hydrogen. Now, let's talk about ferrofluids.
Ferrofluids.
NASA first developed ferrofluids to deal with the flow of liquid fuel and the weightlessness of space. It has magnetic material suspended in the liquid, so it can be controlled by magnets.
I didn't realize how harsh it is in space. I think we really need to learn more about how space travel affects the human body.
Why don't you contact Dr. Schaffner at NASA Johnson Space Center in Houston? He'll be a big help.
Thanks, Dr. D.
Go ahead and enjoy the rest of the exhibit. Oh, by the way, I hear that Bianca's going to space camp. I'm sure she'll also learn a lot about being an astronaut.
RJ's got my bags. Now, make sure that you all run at least 2 miles a day. It's never too early to get a start on your preparation.
And you remember to report daily about what you've learned about working and living in space. Even areas that aren't directly involved with astronauts. You know, manned and unmanned.
Of course. Are you running in those shoes? You need better arch support.
Have a nice trip, Bianca. Keep in touch.
See ya.
So what's up? Will Bianca's training pay off? Will she have the right stuff for space camp? Will RJ keep up his fitness training? Find out in the next episode of The Case of the Great Space Exploration.
Don't forget to look for the answers to the following questions. Why is it important to exercise in space? Why are calories important? Why are robots important to the future of space travel?
Welcome to Huntsville, Alabama, a home space camp where kids get the chance to get behind the controls of a NASA space shuttle and simulate a mission in space. It's the next best thing to being a real astronaut. In fact, you spend the entire week doing exactly what they do. Training, working in teams, problem solving, and of course flying missions. But I'm getting ahead of myself. I've got to meet my team members, but I'll be sure to keep you posted as I learn more.
There you are. Where were you? We were supposed to meet at the track to run this morning.
I've been here all day.
What happened?
Well, it turns out Bianca's right.
I know. She usually is. Isn't that why we're all getting in shape?
No, I mean the shoes. After careful study, it's clear that the shoes, though very cool, are not the best things for running.
I never really took that kind of thing seriously.
Remember last spring when you tried to catch up to the bus in your dress shoes?
Sure.
And you could barely walk for the next 2 days? That could have been a result of bad equipment.
Wow. If something as simple as shoes can make such a difference, then I wonder what kind of equipment they use in space when they exercise.
Me too. That's exactly why I'm here. Research.
I thought you were focusing on unmanned missions in space.
I am. But Catherine called me last night. She's going down to Houston with her dad for the rest of the week.
What for?
She's gonna meet with Dr. Grant Schaffner to learn about the effects of space travel on the body.
Okay, but I still don't understand why that would send you to the library. Not that there's anything wrong with the library.
Oh, sorry. The connection is space travel. If it has an effect on human beings, then it must also have a significant impact on cameras, robots, sensors, and everything else that's involved in the missions. So I came here to learn what space is really like.
Wow. I think I'll head back to the treehouse and catch everyone up on our progress. Let me know how it ends.
No problem.
Dr. Schaffner works with fitness testing and exercise equipment at NASA Johnson Space Center. We met at the bioastronautics lab.
I hear you want to learn how space affects the body.
Yes, we're doing research on the future of space exploration, and we're curious as to what the effect of long-term space flight will have on the human body.
Exposure to spaceflight is very similar to prolonged bed rest. During prolonged exposure to weightlessness, the body gradually degrades and loses bone mass, muscle mass, and endurance capacity.
Can these problems be prevented?
We're not sure if they can be totally prevented, but with proper exercise and nutrition, the effects are minimized.
We know how important it is to be in good physical condition, even if you aren't an astronaut. But do astronauts have to be in super condition?
Actually, there are no physical requirements other than to be healthy and to pass a physical examination. But all astronauts should be in good physical condition.
How is exercise in space different from regular exercise?
Exercises performed in space are similar to exercises done on Earth, but with a few differences. Astronauts use a cycle ergometer, treadmill, and resistive exercise devices for strength training both on Earth and in space. However, the equipment is just designed a little differently for space.
How is the equipment different?
The equipment has to be lighter because it is very expensive to carry mass into space.
When you exercise on Earth, you work against your own body weight. What do astronauts do in a weightless environment?
We use bungees or other devices to simulate gravity loading while running on the treadmill. And we increase the amount of resistance for some resistive exercises.
Why is it important to exercise while in space?
In space, exercise helps limit the amount of bone or muscle loss. Astronauts who are able to complete the exercise program return to Earth in better shape and recover faster.
What happens if they don't exercise while in space?
Those astronauts are at greater risk for bone fractures and have to complete a longer rehabilitation program.
What concerns are there for the astronauts that are going to Mars and beyond?
One concern is that the exercise equipment be very reliable. If it breaks down and is not repairable, then there would be serious health risks to the crew. Also, due to the small space, only a limited number of devices can be used.
If exercising is important in space, isn't eating right also important?
You bet, but the real expert is Miss Davis Street. Let's see if she can meet with you.
Dr. Schaffner said you had some questions about nutrition in space.
I'm curious, are nutritional needs different in space?
Good nutrition is critical for all aspects of human health on Earth. While there are some specific differences during space flight, just like on Earth, we need to make sure that astronauts are able to do their jobs while they're on the mission.
How do you do that?
We make sure they have enough calories, vitamins, and minerals to maintain energy levels and good health.
What are calories?
Food provides us with the energy to perform our daily activities. The term calorie is a way to measure energy, either in the foods we eat or in the activities you perform.
Why are calories important?
To maintain an appropriate body weight, we must balance energy in the foods we eat with energy we expend during physical activity. In other words, calorie intake must match calories burned, or you will lose or gain body weight.
How do we know how many calories we need?
There is a formula to calculate a person's resting calorie needs, or BMR, basal metabolic rate. Once you know your BMR, you multiply it by a factor depending on low, medium, or high activity level.
To learn more about BMR, visit the NASA Sci Files website. So calories are pretty important.
Yes, but remember, it's not just important to eat foods with the right number of calories, they also need to be nutritious.
How can you determine if the foods you eat are nutritious?
One way is to follow the food pyramid as a guide to healthy eating. There are 6 food groups: grains, vegetables, fruits, milk, meat, fat and sweets. Each level of the pyramid represents the correct number of servings of each group.
What is a serving?
A serving is a recommended portion size and is usually measured in ounces, cups, teaspoons, or pieces, depending on the type of food.
Is there anything else that we can do to make sure that we eat healthy?
Yes, you can also read nutritional labels to find foods low in saturated fats and sugar and higher in fiber, protein, vitamins, and minerals.
So how do astronauts make sure that they eat healthy and get the right number of calories while in space?
Nutrition experts help the astronauts plan proper menus for a space flight. Astronauts like to have a choice in their diet, so various foods are prepared just like they will be in space.
Variety in menus is always very important.
Then the astronauts conduct taste tests to select their favorite foods while creating a nutritionally balanced meal.
It doesn't sound that much different than going to a restaurant that serves nutritionally balanced meals.
It is very similar. We also help astronauts keep track of what they eat on orbit to make sure they maintain a healthy diet.
Thanks for all your help, Miss Davis Street.
You're welcome. Call if you have any other questions.
I will. Bye.
Bye.
Hello, RJ. What's in the bag?
New shoes.
Actually, I think you'll be fine.
What do you mean?
Well, I've been going over Catherine's get up and go sheet from her visit with NASA Johnson Space Center. Apparently, you don't need to be a marathon runner to be an astronaut.
I know. I also checked out a report.
Isn't that good news? You can just take the shoes back.
I think I'm gonna keep them. Remember, it's important to be physically fit. And good shoes are important for healthy feet. I just hope Bianca will lighten up a bit.
I sent her Catherine's report, and it looks like we have a pretty good handle on how manned missions will affect the body.
Yes, but I think we need to learn more about an astronaut's diet in space. Miss Davis Street made it sound pretty important.
I've got just the thing.
The NASA Sci Files Kids Club?
You got it. It looks like Maryvale Elementary School in Rockville, Maryland is studying nutrition.
Cool.
And the mentors from the Society of Women Engineers are helping out.
To learn more about the Society of Women Engineers, where you can get a free classroom mentor, visit the NASA Sci Files website.
Here they are now.
Hi, I'm Josh. And I'm Tracy. You're just in time. We're ready to evaluate our astronaut menus.
Wow, that sounds like a difficult task. How do you know what to plan for an astronaut?
Right, like you can order a pizza in orbit.
At first we didn't. We just planned what we thought would be a good diet for an astronaut.
Then we decided to look at our own diets and wrote down everything we ate the day before.
Next, with the help of our mentors from the Society of Women Engineers, we did some research to learn about serving sizes. We were surprised to find out that a serving size is not what we thought it was.
What do you mean, not what you thought it was?
We learned that serving sizes listed on nutrition facts labels are often larger than serving sizes listed on guides to healthy eating.
For example, did you know that a large bagel is actually about 3.5 servings of grain instead of 1?
That's a big difference.
Large bagel with cream cheese.
What other factors do you consider when planning a menu?
We learned that calories are very important in order to maintain appropriate weight and to give you enough energy for the day.
And that the number of daily required calories is determined by your age, weight, height, and activity level.
Although everyone is different for this exercise, we estimated that an average astronaut would need about 3,000 calories.
Many very large bagels, extra cream cheese.
And the calories need to be balanced throughout the day to help maintain a good energy level all day long.
That's a lot to remember in planning a menu.
It becomes even more complicated when you consider nutrition.
We learned from Miss Davis Street that the food pyramid can help you with nutrition.
Yes, the food pyramid showed us how many servings of each food should be consumed in a day.
Did you know that you need 6 to 11 servings of grain, 3 to 5 servings of vegetables, 2 to 4 servings of fruit, 2 to 3 servings of milk, 2 to 3 servings of meat, but only 1 serving of fats and sweets?
Candy bars aren't considered grain, are they?
No. I think we need to make some major changes to our diet.
That's exactly what we thought.
We found out that astronauts say that food tastes different in space. They also like a lot of variety in their diet. They also like spicy foods such as salsa.
And we didn't even think about crumbs floating around in space, so no crackers for the astronauts.
Did you know that they don't even have a refrigerator on the space shuttle?
That would be rough. No frozen pizzas.
Well, after we finish our research, we began to evaluate our menu.
We think we have a good menu now for our astronauts, but we are going to share it with our class and get their suggestions.
That's great. It's always good to get advice from lots of people. You never know where you'll get a good idea.
Well, we better get back to the discussions. We'll post our results on the website.
We'll be sure to check it out.
Thanks for sharing your research with us.
You're welcome. Goodbye from Maryvale Elementary School in Rockville, Maryland.
Wow. I never knew there was so much to think about in planning a healthy diet.
All this talk about nutrition and calories is making me hungry.
Me too. Hey, why don't we stop by my house to grab a quick bite?
Cool, I'll meet you there. But first I need to stop by Dr. D's. I have a few questions I'd like to ask him.
What questions?
Well, we have a good idea about the body and how to prepare it for space travel and keep it fit while in space, but we still need to learn more about unmanned missions. We know space is an extremely harsh environment for people, but what about robots?
I'm sure Dr. D would have some ideas.
Hi, Dr. D. It's nice to see you're finally taking a break.
Break? This is serious robotics research.
It looks like Lego, Dr. D.
It is Lego, but it's also a computerized robot.
That's pretty cool. What does it do?
Here, let me show you. This robot is programmed to go forward and avoid obstacles.
How does it do that?
It has a bumper with a touch sensor, which causes it to back up and then move around any object that it runs into. That's pretty important, especially if a robot is exploring Mars, where there is about a 10-minute time delay between questions sent and answers received.
So are there other ways to avoid obstacles than just knowing how to back up when you hit one?
Yes. One example is the Mars exploration rovers that use pairs of cameras spaced some distance apart.
2 cameras, like 2 eyes. So the rover has depth perception, and it can tell how far away things are.
That's right. 3D images help the onboard computer plot a path that avoided obstacles.
Didn't the rovers only go a short distance from their spacecraft landers?
Actually, the Mars rover named Spirit did travel for only about 10 seconds at a time before it had to stop and consider its next step. But it did travel a total of several kilometers.
So what else can your robot do?
If I place these light sensors on the robot, it will follow this black line. It is programmed to go forward until it hits black, and turn away from the black and go forward again.
Kaylee learned that robots are very important to the future of space travel.
That's correct. Robotic explorers will lead the way, followed by human explorers who will conduct in-depth research.
Aren't robotic probes also able to collect data for long periods of time?
Very good. For a Mars mission, robotic explorers are especially important because travel to Mars is a very lengthy process for human beings.
Doesn't it take just as long for a machine to get to Mars?
Yes, it takes about 8 months to get to Mars, but you don't have to bring a robot back to Earth.
I guess 16 months of food, oxygen, and water could be a challenge.
Actually, it's a lot longer than 16 months. Travel to and from Mars requires proper planetary alignment. Once you get to Mars, you'll probably have to wait 10 months or longer if the alignment is correct to come back.
We learned that the harshness of space makes it difficult for humans to travel. Is the same true for robots?
You bet. Robots have to be shielded from radiation and also protected from temperature extremes.
Dr. D, can we borrow your robot and take it back to the treehouse?
No problem. In fact, let me give you an assignment. Try to find several new things for the robot to do.
And then we can sell the robots to NASA for future missions.
So what's up? What else do the treehouse detectives need to know about space? How will humans overcome the harshness of space for travel to Mars? How will robots help lead the way to Mars? All this and more when the NASA Sci Files continues.
Don't forget to look for the answers to the following questions. What are galactic cosmic rays? Explain how spacecraft will be self-healing in the future. Why does NASA need new propulsion systems?
Trevin, Houston, how do you read us?
Roger, Houston. We're at Mach 10.5 and everything looks okay. Guys, I'm reviewing protocols for an upcoming mission. It's so cool because you work directly with mission control to troubleshoot and solve problems throughout the entire mission simulation. Right now I'm reviewing re-entry and landing procedures after successfully launching a new satellite to track RJ's exercise program. The counselors monitor your progress closely, and they even introduce problems into the mission simulation for the teams to solve. You really have to be prepared. Keep up the good work, RJ. Over and out.
Kind of goes against the whole idea of working out, doesn't it?
No, that's the beauty. No fat frozen yogurt with sugarless sauce and toppings, and it even has fresh fruit. It's totally healthy.
I'll just stick with the water.
I have to admit, Bianca's right. Ever since we started exercising, I feel great.
We're not quite ready to go into space, but we're getting there.
Dr. D's comments on the potential dangers of space travel do have me a little concerned.
Me too. I've been going over all our research, and the radiation problem seems critical.
So what do we do next?
Time for the problem board. We know that space is an extreme environment.
And NASA trains astronauts to live safely in that environment.
And astronauts will also need to learn to live on the moon and Mars.
So what do we need to know?
We need to know more about how astronauts will deal with radiation in space. Catherine mentioned in her report that she might be able to meet with Mr. Mark Wayland at the NASA Johnson Space Center to learn more about radiation.
Good idea.
We might even be able to learn how to send a triage detective to Mars.
Excellent idea. Wait, what, send someone to Mars? Are you crazy?
I'm fine. Corinne is going to stop by the Mars Society's remote habitat in Utah. It actually simulates what working and living will be like on Mars.
That is really cool.
Where are you going? Up to see Dr. D?
No, Dr. D isn't home. I'm going to get another banana split.
You're kidding.
No, when you eat the light version, sometimes you have to eat twice as much to fill up.
You'll never learn.
Hi, Mr. Weiland.
Hi, Catherine. I'm glad you could stop by. I understand you want to learn more about radiation in space.
Yes, we've read that radiation is very dangerous, but we're not exactly sure what it is.
Well, radiation is one of the top biological concerns for our astronauts. There's two basic types of radiation, light and particles.
How is light dangerous?
Light comes in many different forms. The low-energy visible light that you're familiar with isn't dangerous, but light comes in a high-energy form called ultraviolet.
Isn't that what causes sunburn?
Well, that's right. X-rays and gamma rays are another form of light with more energy than ultraviolet, and they can cause serious damage to your body's cells.
What about the particles?
Very fast-moving particles are considered to be radiation. One example is high-energy protons, which are released by flares on the sun. Another even more dangerous type of radiation are galactic cosmic rays, or GCRs.
What's a galactic cosmic ray?
GCRs are extremely fast-moving protons and nuclei of elements such as iron, silicon, and other elements that come from outside our solar system.
Why are they so dangerous?
They can penetrate more than 100 centimeters into materials and can cause a lot of cell damage. They are also very difficult to shield against, and they can even create additional radiation when they collide with metal spacecraft.
Wow. I've heard that radiation can increase your chances of getting cancer. Is that true?
That's correct. The greater the radiation exposure, the greater the risk of getting cancer and other effects such as cataracts, which is a clouding of the eye lens.
What determines how much exposure you get?
The length of the mission is one of the most important factors. A mission to Mars could take several years. Longer missions mean greater health risk from radiation exposure, especially compared to space shuttle missions, which are much shorter. However, NASA is working hard to reduce the risk.
What are they doing?
They're developing better shielding materials that will prevent the radiation from reaching the astronauts in the spacecraft. And high exposures can also come from very intense events, like solar flares.
Isn't that when the sun has a solar storm?
Very good. If you can monitor the sun for solar storms that produce these flares, then you can warn the astronauts to avoid spacewalks and to enter specially shielded storm shelters in their spacecraft.
Is there anything that can help the body handle the effects of radiation exposure?
Well, NASA is looking at how a healthy lifestyle, including dietary vitamin supplements, might provide protection. They're also looking at the role that age, gender, and/or genetic factors play in how the body responds to radiation.
Wow. If radiation is such a problem for astronauts, why don't we have to worry about it on Earth?
We do have some radiation on Earth, but we're protected from most of it by something the astronauts don't have, an atmosphere.
Yes, I learned in my science class that an ozone layer of our atmosphere blocks a lot of the ultraviolet light from getting to Earth.
Well, that's correct, and it also absorbs a lot of X-rays, gamma rays, and high-energy particles. Charged particles, like cosmic rays and protons from the sun, are deflected by Earth's magnetic field, and Earth itself acts like a big shield.
I'm glad that we have some protection. Radiation sounds pretty serious.
Yes, it is. So don't forget, you should always wear sunscreen when you're working or playing outside.
Don't worry, I will. Thanks, Mr. Ryland. You've been a big help.
You're welcome, Catherine, and good luck.
Hi, guys. It looks like you've been working hard on the unmanned missions.
Along with research, we've been working with LEGO to build possible Mars explorers.
Cool.
Of course, we read all of your reports on the internet.
Having access to the internet is a wonderful thing. Speaking of the internet, you can always find great tools for research on the NASA Sci Files website.
Are you ready to go to the next level?
What do you mean?
Well, we've been working on different aspects of space travel, but there's one area that we haven't explored.
Like what?
Dr. Herb Waite from the University of California, Santa Barbara just sent us an email.
Doesn't he research bio-inspired nanotechnology?
Right. He referred us to Miss Dana Novak. She's helping him in his research. Here she is now.
Hi, you must be the Treehouse detectives. Dr. Waite said you would call. How can I help you?
We are researching space technology to learn more about the future of space exploration.
What does bio-inspired mean?
Well, it simply refers to any technology inspired by biology. For example, when George Demestrel took his dog for a walk one day, he saw that they both had burrs stuck to them. He looked at a burr under a microscope and saw hooks and loops. That inspired him to invent Velcro.
What a great invention. I use Velcro all the time.
What plants or animals do you look at for inspiration?
Right now, we're investigating mussel threads and bloodworm and clamworm jaws.
Mussels, clamworms, and bloodworms? Sounds interesting, but why exactly are you interested in worm jaws and mussels?
If we're going to explore the moon, Mars, and beyond, then we need new, advanced, and self-healing materials for spacecraft construction.
What do you mean by self-healing?
Think about what happens when you accidentally cut yourself. It's amazing to watch how quickly your body acts to mend the wound. Like this model, we're trying to understand how to give composite materials those same qualities. This model demonstrates how two different types of bonds within a material work together to self-heal.
And why is that important?
One weakness of current composite materials is that they tend to form tiny hairline cracks, which can lead to major damage over time. In long-distance space exploration, repairs won't be easy.
Right. There won't be a spare parts store you can stop at while in space.
Nope, there won't. However, with new high-performance materials, such as the self-healing materials, we will be taking the first step in building spacecraft capable of traveling millions of miles from Earth that can fix themselves.
That's awesome. But I still don't understand what mussels and worm jaws have to do with it.
Nature specializes in how to put materials together in the most effective and efficient ways. We look at the mussel threads because they're very strong, yet thin and lightweight.
It's amazing how much we can learn just by looking at nature.
We can learn how to make materials that recover quickly from stress. Think about when you buy a six-pack of soda. When you take a can out of the plastic loop, the plastic stretches but is difficult to break. Nature inflicts damage on the mussel threads just like you do on the plastic. We call this damage creep, and it is undesirable. However, in nature, many materials that experience creep recover from it, and we're studying the mussel threads to learn how.
What about the blood and clamworm jaws?
The jaws appear to be just as resistant to abrasion as the tiles on the space shuttle, yet they have only half the weight per equal volume.
We learned in the case of the challenging flight that weight is a very important factor. The lighter the airplane or spacecraft, the less fuel it needs.
That's right, and we hope to learn not only how to make very lightweight spacecraft materials, but also tougher ones.
Why do the materials need to be tougher?
The materials used for spacecraft are subjected to enormous stress, so it's crucial that they be tough as well as self-healing.
Sounds like this research is exciting. Thanks, Miss Novak.
You're welcome. Keep up the investigation and call me back if you have any other questions. Bye.
That was impressive. Never thought that studying mussels and worms could help us learn about traveling through space.
But I'm still trying to figure out how we're going to do it. I mean, what will our future space vehicles look like?
I'm not sure. Maybe Bianca can help us.
Well, she's been training down at space camp, but I don't think their program includes future spacecraft.
No, but they are close to NASA Marshall Space Flight Center. I emailed her last night. She wrote back and said she was meeting with Mr. Cook.
Way to go, Catherine. Have you heard from Dr. D yet?
No, wasn't he working with you and Tony?
Well, we talked to him a couple days ago, but we haven't heard from him.
Maybe Bianca gave him a new fitness program to work on, too.
Well, if so, maybe we should call his house. He may need some help.
Mr. Cook agreed to meet me at NASA Marshall Space Flight Center, where they test rocket engines for spacecraft. They call it the Propulsion System Component Testing Facility. Of course, I had lots of questions. So how is NASA researching new spacecraft for the future?
One way is through propulsion. With the new exploration vision, we will need propulsion systems that will be low cost and will enable rapid, safe, and reliable access to, in, and from space.
So why do we need new propulsion systems? Aren't the old ones good enough?
Most U.S. propulsion systems are based on 1950s and 60s technology. They're high risk and expensive. Right now, it costs $10,000 per pound to put payload into Earth's orbit.
Wow, that's a lot of money.
Exactly. So for us to carry out the exploration vision, the missions must be affordable, the reliability must be increased, and we must find a way to rapidly and safely take us beyond Earth's orbit to the Moon, Mars, and beyond.
What types of propulsion systems are being researched?
The primary ones for exploration are chemical, like these here, nuclear, electric, and propellantless propulsion systems.
What's a propellantless propulsion system?
One type is a system that uses solar sails. These are sails much like those found on a ship. Solar sails are made from thin layers of mylar and act like a very large mirror. As photons of sunlight strike the sail and bounce off, they gently push the sail along.
How does electrical propulsion work? You can't have an extension cord in space.
No, it uses electrical energy from a solar array to accelerate a propellant. There are three types of electric propulsion systems: electrothermal, which uses electrical heat; electromagnetic, which creates thrust using a magnetic field; and electrostatic, which uses charged particles in an electric field.
Don't we currently use chemical rockets?
Yes, and they have been the primary means for transportation in space because of the very large amounts of thrust they generate that are needed to overcome Earth's gravity. As fuels become more advanced, chemical propulsion will continue to play a vital role in space transportation.
They all sound great, but isn't one propulsion system better than the other?
Well, there are pros and cons to each system. The choice of propulsion system depends on the energy requirements of the mission, its duration and destination, and whether it is robotic or human.
I can't wait to travel through space. It's so exciting.
Yes, it is. So keep studying your math and science.
Don't worry, I will.
Oh, by the way, Dr. D called. He said he wanted to meet you over at the Neutral Buoyancy Laboratory.
Dr. D at space camp? That's strange. Well, it is Dr. D.
Attach stabilizer into position on both the array and above auxiliary power panel and lock into place. Roger. Fully deploy array by rotating handle counterclockwise. Roger.
Dr. D, is that you?
You bet. I'm training for a spacewalk working on this underwater solar array.
Of course. We learned from Dr. Utley in the case of the inhabitable habitat that astronauts learn to work in the weightlessness of space by diving into a huge tank of water called the Neutral Buoyancy Laboratory.
That's correct. It takes a lot of practice to prepare for space travel.
That's what I love about Space Camp. We get to practice, they emphasize the importance of teamwork, and of course I'm looking forward to the simulators.
Simulators are great. They allow you to experience what space is really like. Let's go check them out.
This is the space shot.
Great. It simulates liftoff.
Doesn't liftoff make astronauts feel heavy?
We'll see. You just experienced 4 times the force of gravity, just like the Apollo astronauts at liftoff.
Can we do it again?
Sure. 3, 2, 1.
Dr. D, I also felt weightless for a few seconds at the top.
It was because you were freely falling. It's not quite free fall, but if you go to the moon, you will only weigh 1/6 of what you do on the Earth.
That's a great weight loss program.
Let's see how you do, weighing only slightly more than 2 gallons of milk. Buzz Aldrin said that galloping like a horse was easier than jogging. But why don't you try the bunny hop? Awesome.
Training like this before going to the moon is a great idea.
Now that you've experienced walking on the moon, you need to train for re-entry into the Earth's atmosphere. This is the multi-axis trainer, and trainers like this were used by our country's first astronauts in the Mercury program to prepare for the possibility of a tumble spin during re-entry.
Oh, I almost forgot. You've got to contact the other treehouse detectives. They don't know where you are.
Well, that's right. I didn't tell them. I'll get on it right away, just after I become disoriented. Dear treehouse detectives, sorry about the quick departure. I had some important work to do at space camp. I saw Bianca. I'm sure she will fill you in. Looking good. Maybe just a little longer is all I can handle.
So what's up? Will Bianca survive the rigors of training? Who will be the next generation of explorers to go to Mars? Would you like to walk on Mars someday? Stay tuned for the exciting conclusion of The Case of the Great Space Exploration.
Don't forget to look for the answers to the following questions. What is the X Prize? Why are aviation and space contests important? What is the purpose of simulated Mars habitat on Earth?
Doing all right? Ready to go for this thing? All right.
Today I tested out at 3Gs in the centrifuge. It was a very intense experience as the centrifuge spun around to simulate the heaviness of a rocket launch. It was really difficult to move my arms and legs for such a long time. I've been here at Space Camp for almost a week now, and I feel really prepared for my last mission. Wish me luck.
Exercise has really changed my life. I think I can feel myself getting healthier every time I run.
Maybe you should volunteer for an experimental research project.
Do they give prizes or money?
If they do, don't tell Tony, because we'll find ourselves under strict observation in the treehouse for the next 6 months.
I've spent a few days here before. It's not that bad.
Well, speaking of prizes, Tony sent us an email and said to be sure to check out the X Prize.
There must be money involved.
$10 million.
What? Sign me up. What do you have to do to win the $10 million?
I'm not sure, but Tony said to contact Mr. Eric Lindbergh.
I wonder if he's related to Charles Lindbergh.
As a matter of fact, he's his grandson.
Here he is now.
Hi, you must be the treehouse detectives. I got Tony's email. How can I help you guys?
Hi, Mr. Lindbergh. We want to know more about the X Prize. What kind of contest is it?
It's a $10 million prize to be awarded to the first privately funded suborbital space launch.
That doesn't sound too hard.
Well, to win the prize, you have to be able to carry 3 people to an altitude of 100 kilometers or 62 miles, return safely, that's important, and do it again within 2 weeks.
Okay, maybe that's a little harder. Why was the X Prize created?
The mission of the X Prize is to create a future in which the public can personally participate in space travel and its benefits.
I'm there. Just tell me where and when I can go. How soon can tourists go into space?
Whoa, hold on a minute. No one's won the prize yet, but when someone does win the prize, it'll probably take a year or 2 before the paying public can go and fly into space.
Who started the X Prize?
Peter Diamandis was reading my grandfather's book, The Spirit of St. Louis, when a light bulb went on in his mind, and he thought, that's it. We need a prize for space travel. That's how I'm going to get to space. In 1996, we launched the X Prize under the arch in St. Louis.
Didn't your grandfather, Charles Lindbergh, win the Orteig Prize in 1927 for being the first person to fly solo across the Atlantic Ocean?
Very good. You know your history. People often forget that aviation was developed by contests and prizes like the Orteig Prize and the Bendix Prize. And we hope to do the same thing for space travel with the X Prize.
What will happen to NASA if we have commercial spaceflight?
Well, private industry can often operate more efficiently than government, and private enterprise will allow NASA to concentrate on their core mission of science and exploration without having to operate a space transportation system.
I guess NASA doesn't operate the airlines today, even though in the early years when it was NACA, it was important to the development of commercial aviation.
That's right. And the more people who have the opportunity to fly into space and look at our planet, and experience what those astronauts are telling us as a life-changing experience, the more they'll work harder to try to save our planet and the quality of life that we know for future generations.
Now this is truly exciting. To think that I might get to go to space as a tourist. Thanks, Mr. Lindbergh.
You're very welcome. I'll see you in space.
Fantastic. Next stop, Mars.
One step at a time, Space Cowboy.
Seriously, didn't Tony tell you? Corinne's already on her way to the Mars Society Research Habitat.
Oh, right. I forgot. I can't wait to read a report.
It's like a postcard from the Red Planet. And isn't Bianca's simulated spacewalk happening later today?
Yes, it is. She said we should contact Space Camp's Mission Control this afternoon.
We've got treehouse detectives on Mars, performing spacewalks, developing rovers and landers. We're practically our own mission control.
We are go for liftoff.
Dr. Muscatello said he would meet me at the Mars Analog Research Station, but where is it? My GPS says it should be right about here. Wow, Dr. Muscatello, this looks just like Mars. It is so cool.
Actually, on Mars, it's quite cold, around minus 60 degrees Celsius. If we were really on Mars, you'd be frozen. Why don't you come inside?
If it's so cold on Mars, why do you have the habitat in the middle of a hot desert?
We built it here because this environment not only looks as alien as Mars, but it also exhibits landforms made by infrequent rain and wind that are very similar to the Martian landscape.
What is the purpose of the habitats?
The idea behind the habitats is to build simulated Mars bases here on Earth in places that resemble Mars as much as possible. Then scientists who volunteer their time live and work there and study the biology and geology of these Mars-like environments.
Where are the other Mars habitats?
Oh, we have one in Devon Island, which is in the Canadian Arctic. That's a polar desert just like Mars. A third habitat is being installed in Iceland, which resembles volcanic areas of Mars, and a fourth one is being designed for Australia, which has lots of very dry red desert terrain.
So what kinds of experiments do scientists do in the habitats?
Scientists live and work here just as they would on Mars. One ongoing research experiment being conducted is to look for microscopic life forms called extremophiles that can survive in very extreme environments.
Why do they look for extremophiles?
Mars might have similar organisms, so we need to know where to look and what characteristics they might have. Scientists are also looking at rocks in the desert that have a coating called desert varnish, which looks like a stain.
Why is that important?
The varnished rocks have a biological component that eats the rock. On Mars, the Spirit rovers examine rocks with varnish as well, so there might be a form of life on Mars.
Do you have your own Mars rover?
No, but we do have transportation. We use ATVs just like you did today.
Scientists use ATVs? Why would a scientist need an ATV?
To evaluate exploration techniques, they might use an ATV to extend an astronaut's range. Cliff reconnaissance vehicles can descend steep embankments. Their research might be useful to help us learn how to overcome the limitations of living on Mars.
I would love to live on Mars and ride ATVs.
Well, let's see what it would be like. But first, we have to put on our spacesuits.
Spacesuits? I don't have a spacesuit. Wow, this is great. Do you think that we'll really go to Mars?
Most definitely. We already have the technology to travel to Mars. We would just have to be very clever and use the resources that are already on the red planet.
What kind of resources does Mars have?
The atmosphere of Mars has a lot of carbon dioxide, which you would combine with hydrogen brought from the Earth. With the right catalyst, you make methane, which is your fuel for the return trip home.
But what would happen if you got there and the process didn't work?
With a plan developed by Robert Zubrin and David Baker called Mars Direct, you would send the Earth return vehicle to Mars without astronauts. It would land and start making fuel. Once you knew the fuel tanks were full, the astronauts would leave Earth.
Speaking of leaving Earth, can we go exploring?
You bet, but don't forget your helmet and backpack.
Yes, that's very important.
Are you ready to see Mars?
You bet.
Can you give me the order of switches to deactivate the antenna?
Roger. Turn off B2, B3, B4, B5, and finally B1.
Roger!
Our EVA mission is on target. Going to get the broken antenna.
This is excellent work. Keep up your concentration.
Space Camp, this is Mission Control. The satellite is worse than it was before.
Wait a minute. That sounds like Jacob.
You got me. Catherine, RJ, and I are monitoring your progress from the treehouse.
It looks like you're having a great time. Plus, you've been on some amazing simulators and really experienced space.
Yes, and I learned how important communication and teamwork are in space travel. Here's antenna A, Dr. D.
Got it. I'll be right back with a new one.
For an astronaut to be successful, you have to have the proper training.
That's right. There's a lot of practice, and more practice.
Don't forget, astronauts have to be physically fit, eat a healthy diet, and also practice.
We also learn to avoid spacewalks during solar storms.
Radiation is a big problem in space.
Here is the antenna. Do you have the instructions for installing it?
Affirmative. Space is a harsh environment, so astronauts not only need protection from radiation, but also from the extreme temperatures of space and from micrometeoroids. Installation complete.
Bianca, do you have the order of switches for the reactivation of the antenna?
Roger.
Okay, Treehouse detectives, we have to focus on our task here. We look forward to reading your research report. Goodbye from Space Camp.
It's amazing. It looks like we were learning some of the same things.
Yes, we learned about special materials used to protect both people and spacecraft from radiation.
Like polyethylene.
You mean plastic bags. And we know the galactic cosmic rays are a real problem.
We also learned how astronauts' meals are planned based upon calorie count in the food pyramid.
Let's not forget what we learned about unmanned missions. The future of the space program depends upon robots preparing the way for people.
Wouldn't it be cool if we all became astronauts and worked on a mission together?
Sure, as long as Bianca isn't the commander.
She would make an excellent commander.
And plus, now she has more experience than any of us.
You're right. It would be pretty cool.
Are you going home?
I think I'll go for a run.
Great, I'll run with you.
Okay, I'll run too. Catherine, prepare to be blinded by my pure speed.
The NASA Science Files was made possible through the generous support of Busch Gardens, SeaWorld, and NASA Langley Research Center's Aerospace Vehicle System Technology Office.